Okay, today we're going to talk about a geometric series. And so we're going to talk about what is a geometric series. Similar to arithmetic series, it's when we add up a sequence. This time we simply add up a geometric sequence. For example, if we had 1, 2, 4, 8, 16, this would be the sequence, and then the series would be 1 plus 2 plus 4 plus 8 plus 16, and the answer to the series would be 31 if we added all those numbers together. Now we have the difficult task of developing the general formula for the series. This would be how you would actually write the general formula. So the sum of n terms is t1 plus t1 times r, etc., all the way up to n minus 1. We talked about this in the last class when we first introduced geometric sequence. Similar. Now, I want to develop the formula just using a general example because the developing of the formula is quite complicated. So we're just going to use a general example using the sum of these 4 terms. Okay, so we're going to develop four terms. And then I'm going to give you the formula for the general. If you're interested in seeing the development of the general formula, I can do that at a later date for you. So if we have the sum of 4 terms, now say we label this as equation 1. Now I'm going to times this by the common difference. So in this case, the common difference is 2, right? Because each time it multiplies by 2. So if I multiply this by 2, I end up with 2 times S4 equals, and then I've got 2 times 1 is 2, plus 2 times 2 is 4, plus 2 times 4 is 8, plus 16. That's this equation multiplied by 2. Okay, now I'm going to rewrite this first equation over here. I'm going to say S4 equals 1 plus 2 plus 4 plus 8. Now you'll see what happens when I subtract these two equations. So I get 2 minus 1, so it's 2 minus 1, and the sum of 4 terms equals, now 1, it's minus 1, and then plus 0, plus 0, plus 0, plus 16. Okay, so then the sum of the first 4 terms, if we simplify this, is 15. So now notice this negative 1 here, and this is the common ratio minus 1. Okay, so when you see the formula, you'll see this common ratio minus 1. Okay, here's the general formula. Here's the general formula for finding the sum of n terms in a geometric series. So you'll see that the r is again the common difference, t1 is the first term, and n is the number of terms. Okay, so that hasn't changed much, just a little bit of a different formula that we have to use. So I'm going to circle it there. I want you to pause the video and make sure you have that formula written down. Now I'm just going to show you quickly how to apply it for this specific example, and then we're going to do one more example. Okay, so determine the sum of the first 10 terms of the following sequence. So the first thing we need to do is find T1, find R, and then we have to find the sum of the 10 terms. Okay, so n is going to equal 10 because there's 10 terms. T1 is 5, and R is 15 divided by 5, which is also 5, which is 3. Which is 3. So now we go up to our formula here. Go up to our formula here. And we write it down, and we say Sn equals Now I want the sum of the 10th term, so I'm going to change the n to 10. So I'm going to say S10 equals T1 is 5, and then R is 3 to the power of 10 minus 1 over R is, again, 3 minus 1. So this would be 5, and then 3 to the power of 10 is quite a big number, so I'm going to have to do that in my calculator, and that is 59049 minus 1 divided by 2. Okay, so I'm just going to scroll down a little bit here. Again, you would stop and do this whole calculation yourself. So minus 1 times 5 divided by 2 is 147,620. Big numbers, but you're trying to find the sum of 10 terms, so it's going to get pretty big. Now I've got one more example for you, and I want you to try this one again at home, and we'll bring this back to class. I've given you lots of hints for this question. So it says determine the sum of a geometric series when you don't know how many terms are in the series. Find the sum. Okay, so here is the series. Okay, the first step is, again, to find how many terms, or n, using this formula, and then finding the sum using this formula. Okay, so there's 2 steps to this. I want you to try this on your own and bring it to class.